Dear students, we are studying about structure of atom. In the previous class, we studied about J.J. Thompson's model and Rutherfords model. J.J. Thompson's model and Rutherfords model we studied in our last class. How J.J. Thompson proposed atomic structure? He states that atom is a positively charged sphere in which electrons are embedded in it. That means atom is a cloud of positively charged and electrons are, we can see electrons in some spaces. That is the model proposed by J.J. Thompson. For a certain period, it is believed that the structure proposed by or atomic model of J.J. Thompson was correct. But afterwards, this model could not explain further questions arised from the scientific world. So, another scientist called Rutherford, he was very interesting to know how electrons are distributed in atom. So, he done his gold foil experiment. Gold foil experiment to know how electrons are distributed in atom. See, J.J. Thompson said that atom is a sphere consists of positive charge. Okay, here in gold foil experiment, in the last class I said why he selected gold foil. Then in gold foil experiment, alpha particles are bombarded with the gold foil. Why these alpha particles are selected? These questions we discussed in the last class. Okay. In Rutherford's model, after doing the gold foil experiment, the observations were entirely different. He got unexpected observations from the gold foil experiment. See, on the basis of this Rutherford's gold foil experiment, he saw that atom has a positively charged center. Means positively charged particles. Which are positively charged particles in an atom? It is protons. Protons are present inside the nucleus. Atom has a center and that center he called as nucleus, and protons are present inside the nucleus. Okay. Then he said electrons are revolving around the nucleus. Electrons are revolving around the nucleus through different paths. Electrons are revolving around the nucleus. We know when a body is revolving, they gain acceleration, isn't it? Due to the movement, due to the revolving, they got acceleration. Due to this acceleration, the revolving objects will lose energy, and finally what happens? Their energy decreases, then decreases gradually. They will lose their whole energy, and this particle will fall into the nucleus. That is due to the acceleration, particles, revolving particles lose energy, and at last they will lose a whole energy and they will fall into the nucleus and atom will collapse. But we know atoms will not collapse, atoms are stable. See, I am having a pen. This pen is made up of atoms. Everything in the universe is made up of atoms, and atoms are stable. The atoms present in this solid substance is stable. That is why it exists in this state. See, here we know atoms are stable, but Rutherford could not explain the stability of atom. That was the drawback of Rutherford. Then, after studying the stability of atom, another scientist called Niels Bohr. Niels Bohr, he was a Danish physicist. He focused on the stability of atom. the main focusing of Niels Bohr was stability of atom. He focused on the stability of atom. Then he said that the Rutherford, what he said, the atom has a center nucleus and electrons are revolving around the nucleus. That is same for Niels Bohr also, but he said electrons are revolving around the nucleus in discrete path. See, electrons are revolving around the nucleus in discrete path, means definite. Discrete means definite or fixed path. Atom has a center nucleus, protons are present inside the nucleus and electrons are revolving around the nucleus in discrete path. Then whenever these electrons are revolving through this discrete path, they will not lose energy. That means they will not lose energy, then at last they will not lose their whole energy, they will not fall into the nucleus and atom will not collapse, atoms are stable. See, stability of atom was successfully explained by Niels Bohr. See, electrons, protons are present inside the nucleus and electrons are revolving around the nucleus in discrete path or fixed path, and he called these fixed path are energy level. Energy level or orbits or shells, we can call any name. Energy levels, orbits or shells through which electrons are revolving around the nucleus. Did you get the idea? We can compare this model with the solar system. We know solar system, what is the center of solar system? Sun is the center of solar system and other planets are revolving around sun, isn't it? Then these planets are revolving around the sun, even though they will not hit each other, they will not collide each other. Why? Because they are revolving in fixed path, fixed orbits, isn't it? So like that, electrons are revolving around nucleus in fixed energy level orbits or shells. Whenever these electrons are revolving through these shells, they will not radiate energy. That was the that postulate could explain the stability of atom. Then these shells or orbits, we know center of the atom, that is nucleus, and electrons are revolving around energy levels through energy levels. See how he named these energy levels. We will see how Niels Bohr named these energy levels. The first shell, that is nearer to the nucleus, is given, then letter K, capital letter K is given to first shell. Then next one, nearer to the K shell, it is L shell. Next one, M shell and N shell and so on. So the names of the shells are K, L, M, N, etc. Okay. Then how he gave number of the shells. K shell number is 1, N is equal to 1 for K shell, N is equal to 2 for L shell, then for M shell N is equal to 3, N shell N is equal to 4, etc. Okay, understood? The postulates of Bohr's model are only certain special orbits called discrete orbits through electrons are revolving, and his second postulate was whenever these electrons are revolving around the nucleus, they will not lose energy, they will not radiate energy. These were the postulates of Niels Bohr. Okay. This model could explain correct model of atom. Then in the coming class we will study about how electrons are distributed in these shells and the correct, what is the correct now, which model we are following. These things we will study in our next class. Thank you.